Society, the World Academy of Sciences, Indian National Academy of Sciences, Indian Academy of Sciences, National Academy of Sciences, India, and West Bengal Academy of Sciences. She is recipient of Swarna Jayanti Fellowship, MRSI Real Science Annual Prize, TAE Raja Ramanna Prize, P. Sil Memorial Award, Dr. APJ Kalam HPC Award, and JC Bose Fellowship. She headed the Max Planck India Partner Group, Advanced Materials Research Unit, and Thematic Unit of Excellence and Computational National Center. I welcome you, Madam, to this SOAFAL lecture series. And before you will be speaking on Women in Science, a braided trail, I request our Honorable Chancellor Ji, who is a renowned cardiac surgeon and also the Vice Chancellor of this university from 2015 to 2019. Now I request Sir to kindly address the audience. Sir.
Very good afternoon.
Hit full screen.
Yes.
So thank you very much, for inviting about me to speak in this platform. And I was looking through, many eminent women scientists has actually spoken before me on your platform. So I feel really honored and privileged to be a speaker in this platform. So as mentioned, the title of today's presentation is Women. I will also share some of my personal experience with you and tell a little bit about my work, my science that I do, along with the research group I have. And finally, we'll finish with some general comments, which I hope will be useful to all the young girls that are present in today's event. So I come from SN Bose National Center for Basic Sciences in Kolkata. This institute was established in the year 1986 by Department of Science and Technology to honor the life and work of Professor Satyendranath Bose, who is an Indian scientist in whose name half of the fundamental particles of this world, namely the bosons, are known. I think it was mentioned in the introduction a lot about the word quantum, and he was one of the Indian scientists who made a pioneering contribution in terms of development of what we know as quantum. And we hear a lot about quantum, but it started way back. In fact, I feel very honored to say this year we are celebrating the centenary of this pioneering work, which led to Bose-Einstein statistics. And that's the beginning of this quantum journey. But as also mentioned today, my talk will be a little different. So I'm going to talk about the women in science. So I show you a picture of an women scientist. And in the right-hand side, what you can see are the picture of staircases. And you see that the steps of these staircases are very different for that of a man and a woman. When we start in kindergarten in a school, then the step size is same for the man and the woman. But as we move along, as you see, these step sizes keeps on increasing for a woman or for a girl. In fact, the last step that you can see is really, really high for a woman. So you can see that the path or the trail is not the same for a man and a woman, simply being differentiated by their gender. So I think it was mentioned this entire edition is that of Lilavati's daughter. And this is a very famous book which was published from Indian Academy of Science. And the authors were Rohini Godbole and Krishna Ramaswamy. And they collected about 100 biographical essays on Indian scientists in India. And it was published in 2008 originally, and after that several versions have come up, several editions has come up. And I was fortunate that time, I think our Vice Chancellor mentioned me as a young. I'm no longer a young, but that time I was indeed young, and I was very fortunate to contribute an article in that book. So a little bit about my journey, my trail. I started my school in this is Bagbajar Multipurpose School, which is a school in Calcutta, in North Calcutta, where I was born and brought up. And as you can see that it was an all girls school, because that time in a conservative Bengali family, a girl student, a girl is supposed to go to a girl all girls school. So that was the kind of ideas we had. Even for doing my higher secondary, I was chosen, made to choose Bethune College, which is a very renowned college, also in North Calcutta. And again, it was all girls college. I just want to mention, emphasize on this all girls, because that was really the idea and the culture in a common Bengali family. The first, I think, kind of breakthrough came when I, for my bachelor, I was admitted to Presidency College, and that Presidency College was a co-education college, and the girls were not supposed to take physics honors. I took physics honors because I wanted to be a physicist, and in this class of 20, it was a very small class, we were only 4 girl students in that 20 student class. And that was for me a change in culture. In fact, we were so scared initially, we didn't even talk to the boys. So we had a real separation between the girl student and the boy student. But the situation changed very differently when I did my master's in science college in Rajabajar. And the science college, then the ratio between the girl student and the boy student became much better. It became almost 60-40, and the boys became great friend of us, and we really started mingling with the boy student. But in spite of this fact that the girls were a minority in physics, I managed to top the masters in from science college. So I was a gold medalist. You can see that the gold medal from this University of Calcutta was given much later, 2017. And by that time, I'm already a faculty. And this is the picture of my parents, proud parents with me, who initially was a bit hesitant to put me into study with all the other boys, but they finally became very happy. And after that, I joined SN Bose Center, where I am now the faculty and director as a PhD student. And I think men are the main driving and cooperating entity in a woman's life. It is always said that behind a successful man there is a woman, but I think reverse is also true. Behind every successful woman there is a man. And I was very fortunate to meet 2 very important men in my life. The first one is late Professor Abhijit Mukherjee, who was my PhD student, and Professor Indra Dasgupta, who was my cohort at that time. He was also doing PhD under Professor Abhijit Mukherjee. Later on, he became my husband. But these 2 men really, really motivated me, influenced me to take up all the challenges of a scientific career. So I think a message to this young girl should be, it is more to their family. It is the matter of the family encouragement, and having such kind of encouragement. The girls are able to do each and everything if the proper support system and the encouragement is there. After that, I submitted my PhD and also got married, and then went to Europe for my postdoc. The first postdoc was in Onera in Paris, as was mentioned by Professor Nachiketa. And at the end of my stay in Paris, I became seriously ill. In fact, I developed some autoimmune disease, and I was in hospital of Paris and really struggling with my life. But at these points, so my husband, Professor Indra Das Gupta, he was a postdoc that time in Max Planck Institute in Stuttgart. Then came this great man from Max Planck Institute in Stuttgart, Professor Ole Anderson. He was so very generous. He offered me a position in Max Planck, and he said, although he is offering me the position, but I can still continue working with the work I was doing in Paris. So since I was doing computational work, it was very easy to do some kind of a remote working because I used to stay in Stuttgart and go to Paris once in 2 months to meet my supervisor there. So my point is I'm just going to highlight all these important men in my life. And as you can see, I have been greatly motivated, influenced by all these great men. And after that, I returned and I was a postdoc for a very brief duration in ISC Bangalore and then joined directly the SN Bose Center as a young faculty. That time I was just a lecturer. And I was really struggling to continue my research work that I got involved in during my stay in Max Planck Institute in Stuttgart. And I was very fortunate that basically changed my research career completely. I was very fortunate to receive this Max Planck, very prestigious Max Planck partner group, where the support was made completely by Max Planck Institute to build this partner group so that those who are having the postdoc before in Max Planck can still continue their research work as a young faculty. And as you can see that the title of my work was Understanding Physics and Chemistry of Materials, and this is some technical term by some kind of a computational tool. And four such Max Planck partner groups started in India way back in 2004. And you can see that there was an inauguration ceremony in IIT Delhi. And you find my picture with Professor Ole Anderson. And this is a common picture with all other recipients, the other three of this Max Planck partner group. And since then, this initial boost really helped me to shape up my career. And here is a glimpse of the many different talks and the events that I have participated. And one of them is actually a very nice interview. You can all read it. It's in communication physics. And this was a special issue about women in physics. And they took my interview, and I think that interview, if you all read, you will find it in the internet, and it is I think a very nice interview. They really captured some essential thing of my mind and my journey. And there is from Bigyan Vidushi, this 75 women trailblazers of science, and among many illustrious Indian women scientists, I was very fortunate also to take a place. So these are some milestones I believe in my journey. Like 2005, I received the Sharna Jayanti Fellowship, and 2010, I was elected as a fellow of the National Academy of Science as well as Indian Academy of Science. In 2015, I was elected fellow of American Physical Society and as well as received the GAE Raja Ramanna Prize. 2019, I received the J.C. Bose National Fellowship, and 2021, I was elected fellow of the Indian National Science Academy, and also that particular year, I became the director of SN Bose Center. These are some other important events that happened in my life. So coming back from my journey in generally about the women in science, this is actually a very important issue. I was fortunate to have many important men in my life, which made my journey much smoother. Although initially I did face problem because of my very protective family, they were not very ready to send me anywhere which is away from my home. I had to really fight especially with my father, to my higher study for my growth, academic growth. It is important that I go out of my home. But other than these initial five, I must say that my journey has been more or less smooth, and I am immensely grateful to all these men who has been really supporting corners. And so in science, the story is actually can be very different. Many of them must have faced lot more hindrances than what I just told you. So this is we have within the Indian Physics Association chapter which works on the working group towards this equity in gender. And we organized this conference, Pressing for Progress, in 2019, and it was actively participated by many of the women. And you can see me with other colleagues who actually organized this conference. And this issue became so relevant in today's time that this is a picture from the India International Science Festival, which happens every year now. And it was in the year 2019. And you can see then that time the DST secretary, along with all the women, and there was a special session on this women scientists and entrepreneurs conclave where all the women told about their story and their struggle. The Indian Academy, as well as Indian National Science Academy and National Science Academy, all three academies of India have been very sensitive to these particular issue. So this is a book that came out of Indian National Science Academy. It's a book on ethics, and the gender discrimination or the gender bias is considered as an ethical issue. So I contributed a chapter on ethical issues associated with gender bias. You can see my co-authors, Professor Shobana Sharma for TIFR, Professor Shashidhara. At that time, he was in IISER Pune, myself and Rohini Godbole from IISc Bangalore. But this quote here is actually very important. Achieving gender equality requires the engagement of women and men, girls and boys. It is everyone's responsibility. Well, we organized, which was an Indo-French conference in women in science, and it happened in Paris. And you can see in the organizing committee, there were both Indians as well as the French. But what we found, so these kind of ideas or concepts, it's a worldwide thing. It is nothing particular to that of India. As I said, only the numbers are different. They have far more women scientists, women directors, women in the leading position than what we have in India. But still, if you look at the career path or the difficulties faced, the stories behind all their struggle are pretty much similar to what we see in India and in France. So we came up with some kind of recommendation or general ideas, so which I hope is will be actually also relevant in today's talk. That first of all, public attention has been largely focused on women's underrepresentation in politics, business, and public administration, while the existence of gender bias in science and technology has been long been underrated. Only now, everywhere worldwide, people are very vigilant about this gender bias in science and technology. As mentioned, that science is no exception, and it is actually proved with the data. It is nothing the step size, schematic picture that I showed. It is just not schematic. It is actually supported by the data that clearly shows that women tend to disappear as we progress from lower to higher levels of scientific careers. For example, the maximum amount of drop we find that happens in recent time is number of women scientists carrying out their PhD and to the next stage, that of going for a postdoctoral position. Because this is the time the women get married And this is also the time which is the childbearing time. So they become mother and then they take a break and then they become out of this entire journey. And the maximum drop that happens there, that can be overcome only if we have a family support. If the family encourages that they will share the responsibility, and in spite of being a mother, the women can still work. So these are the things which are very, very crucial. And this has increasing negative impact, this drop of these women, on the research quality, policies, scientific results, because this is like the two wings of a bird. A bird, if you cut off the other wing, the bird cannot fly. Similarly, in the society, if you cut off the contribution of the women in terms of their contribution, be it science, be it politics, be it business, the bird cannot fly. So policy efforts, significant, fortunately, there is significance of this issue has been grasped by many institutions, organizations, leading to increasing commitment to gender equality in science. And but still, that is why we are still talking about it. There is enough scope for improvement. First is awareness, supporting all programs with awareness raising activity like today's program, outreach program, interaction with role models. That's very, very important. The girl student, the girls of today will be inspired by looking at some of the established characters already of that of the yesterday. So active mentoring of female young students, explaining the expectation and demands in scientific profession is important. I really mentioned to you some of the part of my journey. One thing I would also like to mention that in my journey, so I got a position in Calcutta, while my husband, he got a position in Bombay, in IIT Bombay. And for 8 years, we remained separated, one in Calcutta, another in Bombay. So that is done, that was done only for the sake of our career, only for the sake of the fact that were interested and we were happy doing science in spite of being remaining separated for 8 years. So these are the things you should be ready to accept. And not only you have to accept, your family has to also accept. Both of our family, my family and my in-laws, they were very cooperative. They understood that for the sake of our own academic interest, it might happen that we will remain separated. So these are the things you need to really keep in mind. Promoting women in leadership position, supporting women to attain key positions in practice of science. For example, there are very, even now, you can hardly count the number of women directors in different research institute, universities as a vice chancellor. Still, this number are too far less compared to what it should be. So this fact needs to be appreciated all over in the society. Recruiting and retaining the next generation of women, there is a big role of the search committees, funding agency. For example, I mentioned about this really small number of the women at the top. And for that, there is a big role of different recruitment committees, the funding agencies. Well, with that, I would like to tell a little bit about my own research. So I do research on computation and I use the power of high performance computing in terms of understanding the problems of material science. In general, I'm interested to answer the question, can computation create next wonder material? As you know, the materials in human civilization are so very important that different ages of material are named after one another, like starting with the Stone Age, the Bronze Age, the Iron Age, the Plastic Age, and to the modern age, which is the age of the silicon. And it was really the farsightedness of Leonardo da Vinci the Italian painter, but he was also a philosopher and he was also a scientist because he had the foresight to tell us that the future age is going to be the design materials age. The precise quote from Leonardo da Vinci was, when nature finishes to produce its own species, man begins using natural things in harmony with this very nature to create an infinity of species. So therefore, the future age is going to be the age of materials, but the materials which are not there in nature, but it's the human being who comes up with these designed materials. One such material are quantum material. I think our Vice Chancellor mentioned about the word quantum. So these are the materials whose properties are dominated by quantum fluctuation, quantum entanglement, quantum coherence. These are all manifestation of the quantum mechanical effects, which was discovered long back and with the important contribution of our scientists like S.N. Bose. So examples are, you have heard about superconductors. It was mentioned about the quantum computers. To make quantum computer, actually you need a platform, a material on which it has to be made. And one such material that has been discussed are the superconductors, the superconducting qubit, and they are all quantum materials because the superconductivity arises because of the quantum mechanical effect. I have put also few other examples. I'm not going to really describe all of them, but if anyone is interested, I can talk little more about it at a later stage, like magnets, topological insulator, multiferroic. All of them are quantum materials because all their properties are dictated by quantum mechanical effect. We cannot use the ideas of the classical world to explain these properties. So the goal is to design new materials like quantum materials with tailored functionality. And to do that, a key role is played by the electrons. So if you take the molecule, it is, or if you take anything that is made out of atoms and molecules, if you break that small atom, inside you will get these electrons and protons and neutrons. And electrons are the particles, one of the fundamental particles that play a key role in making such kind of properties like superconductivity and etc. Electron is the glue that binds these atoms together because to make any material, the constituent like the atoms, they have to bind to each other. So calculate, I am computational person, so I calculate things, calculate electronic properties in an ab initio way or a first principle way is the goal of my research. And this is used in understanding the materials property, like the connection between the structure and the property, like for example, why the glass is behaving like a glass, why a copper is behaving like a metal, why any kind of semiconductor is behaving like a semiconductor. So these kind of understanding we provide through our computation. The other class of problem that we handle is like we know the material has been made, but its functionalities are not fully explored. And through the computation, we basically suggest to the experimentalists, look for this kind of functionalities. So we predict some new functionalities through computation. Computation gives you the power of prediction. And the last category of the problem that we handle is predicting new materials completely. Like that was the goal of the Leonardo da Vinci, that these materials, they don't exist in nature, but through computation we are predicting existence of this new material. And in this case, we primarily use the power of the machine learning and artificial intelligence to predict this new material. And once we have predicted these materials with some kind of targeted properties, we then basically refer it to our experimental colleagues, and many of the materials we have predicted, they have been later made and synthesized in the laboratory. So this is my group. You can see in the group, this is my research group. We have a good balance of men and women, and I'm just highlighting some of my girl students, and they have left the group, and they are doing their postdoctoral research in various places like Trinity College in Dublin and in EPCTP in Korea, in Dusseldorf in Germany. So they are not really confined to their own country for the sake of their higher education. They have really traveled far. And these are two examples of my two girl student, PhD student, who later on has become very successful. Dr. Hena Das. So he did for her postdoc. She traveled to US, went to Cornell and MIT, and now she is an associate professor in Tokyo Tech in Japan. Dr. Shostika Chatterjee, she did her postdoctoral study in Indian Institute of Science, Bangalore in IIT Kharagpur, and now she is an assistant professor in Indian Institute of Science, Education and Research in Kolkata. So she made her life by traveling abroad. Shastika, on the other hand, was very much restricted by her family constraint because she got married at an early age. I would consider even before submitting her thesis, she became mother very soon. So for her, traveling abroad was so much impossible. But in spite of all that, she never gave it up. She really kept her fight on going, and that's the reason she is now an assistant professor in such a prestigious ISAC Kolkata. And these are some of the glimpses from my group. So we just don't do only work, only science. We also have a lot of fun. And you can see these are basically the picture of my group at different point of time. And all the time you see, we will find a good mixture of the girls and boys. And the girls, they say the boys are the very important component of their life because they became the most good friends and the kind of person, very good collaborator, a friend always in need. And these are some more pictures with some of my girl students sharing some of the happy moments, the recognitions they got in different conferences and scientific activities. So I think I was asked to give a message to the girl students here. So I will show you a cartoon picture. And this is a cartoon picture. I hope it's visible. You can see there is a man who just opened the door. And inside the room, there are three women. And this man is asking the question, excuse me, ladies, could you tell me where the selection committee members are? So this man actually is thinking these women cannot be even the selection committee member because only the men can be selection committee members. So answers these women, here we are. So this is the world that we are dreaming about, and this dream all the girls present today in the audience, you should also have. You should point where the men will be at the other side and you will be really at the top at the commanding position. That's possible, very much possible. Only your journey can be little tougher than that of the man. Therefore, don't give up, don't lose hope, keep on fighting. So, with that, thank you very much for your attention, and I would like to end my talk here.
Thank you, madam. Thank you for a very enlightening speech and that to deliver in such a beautiful language with your very simply. So I think it is so much understandable, and that is what kind of lecture actually we are looking for. So it is really motivational. I think we can take some of the questions, madam, from the young students because there was not much physics. So I think all of them, though they are from different backgrounds, they can ask, they can interact with you.
Sure.
So I hope now the uh, platform is open for questions. Yes, please.
I think I can see a question in the chat box. Should I read it out?
It's form. Right, it's eight.
Good afternoon, ma'am.
Good afternoon.
So, ma'am, my question to you is, what do you mean by wonder material and quantum material?
So I think what I meant by quantum material, are you a student of science?
Yes, ma'am.
You are a student of science. You are from which, are you from college?
Yes, ma'am.
So have you studied physics?
Yes, ma'am, in plus 3.
Yes, studied physics in plus 2.
In 12th standard? Yes.
Yes.
So if you have studied physics in 12th standard, you know there is Newton's laws of motion, right? So for example, apple falls from tree and falls on your head. That motion is given by Newton's law. That's a classical world. We can see, for example, what we see around us and what we feel around us is a classical world. On the other hand, if you try to explain the motion of electron, for example, when you break up a material, for example, if you break up that apple into little piece and go really deep into smaller length scale, you will find fundamentally this apple was made out of some atoms. And if you break that atom, you will get also some electron. Okay. The motion of atom I can explain with this classical physics, but the motion of electron I cannot explain with classical physics. Okay, I need quantum physics. Now the properties that this falling of apple is one kind of property, but the property, for example, iron is a magnet. Okay, it's a magnet, right? That property, to explain that property, you cannot explain just by classical laws. So to explain such properties, you need quantum mechanics. And normally, if you really cool down a material down to 0 Kelvin, you see such kind of quantum effect. But quantum materials are those, even at finite temperature, to explain their properties, you need the help of quantum mechanics. For example, the magnetic properties, the fact that it is a magnet, that actually needs the help of quantum mechanics to explain their properties. So those materials, we are calling them as quantum materials. They are not like normal materials where their properties can be explained by classical physics. You need quantum physics to explain their properties. Does it explain your answer your question?
We can take two questions from the chat box, madam.
Yes, there are several questions in the chat box. So I think one of the question was how can advancements in quantum physics and development of quantum materials revolutionize current technology? Okay, so I will take the first part of this question. I think it was mentioned like quantum computer. So in a classical computer, you know you have 2 bit like 0 and 1. But in quantum mechanics, you do not have just 0 and 1, but you have superposition of zeros and 1. So therefore, you just not use only two different states, 0 and 1, but in between 0 and 1, there are many states that you can make use of. So in that way, you can come up with a quantum computer. There, the algorithm architecture will be very different from that of a classical computer. Similarly, you can think of quantum communication. The modern day, the communication you think of, they are classical communication. But if you can use the rules and laws of quantum mechanics, this communication will be more efficient in the sense that the security of the communication is actually a very important thing, because you communicate from one information from one side to another side, and you want this information not to be seen by anyone else. That's called the security. And with the classical protocol, this security is not as strong as the quantum security. So these are some of the, I can keep on talking about it, but I will just stop here, because these are some of the real advantages of quantum physics in the human mankind, or for the advancement of the society. Then the same person asked the thing, that was the second part: can women scientists bring to this cutting edge field to ensure diverse perspective and innovative solutions? In fact, in these national quantum norms, and in these national quantum mission, I can tell you, by the women scientists. So the women scientists, they are as effective as the men, and the brain actually doesn't have any gender. Brain doesn't know whether it's a man or a woman. So this women scientist has been very, very effective, and they are taking lead role in this national quantum mission. So I think the other question, I hope it answers the question that was asked by, I think, Bishant Naik. Can they talk? They cannot, right?
Yes, madam, there is there are so many questions you can combine the questions.
I will take, Bishant just replied, he said yes. Then the next question, I think, was, uh, what are some of the biggest challenges you faced as a woman in science, and how you have navigated these challenges? So I think I will just simply give you the answer. The women needs to be much more motivated than a man. For example, uh, after I have gone abroad, and when I fell sick, and I could have given up at that point itself and come back to my country, to my family, which I didn't.
Morumi, have you got a question? Please ask. You can come here and ask.
Yes, thank you so much, ma'am, for your wonderful talk. I'm John Rabo Murunji, and I'm an international student from Uganda. So my mom is kind of seeking your opinion on one of the systems that my home country has adopted in line of increasing the number of the women in science and in physics particularly. So there is a system whereby the ladies or the girls that are joining university have a lesser cutoff point compared to the men. So, according to your opinion, ma'am, do you think such an initiative would be appropriate, or it may instead just to feel comfortable and just think that everything will work out at the end? Thank you so much.
Thank you. I think you asked a very, very important question. There are two approaches to address this women in science issue. One is what we call as top-down approach. That means it comes from government making policies, making certain reservation for the women. You just mentioned the cutoff being different for men and women. So these are called top-down approach. And the other approach is a bottom-up approach, which comes from the family. For example, I send my daughter to school, I send my son to school. Do I give additional support in terms of having additional tutor for both my son and daughter? In many cases, no. For example, the son is sent to a better school than the girl. That's a discrimination starting at home. So if we are conscious about this discrimination right from home, then at the bottom level itself, you are out of this discrimination. You are giving equal opportunity to your son and your daughter. In that case, the top-down approach may not be even needed. The government thinking of different cutoff for girls and boys. So at the moment, the bottom-up approach takes time to develop. So that is the reason now government has to intervene and do this top-down approach. But I am strong believer of this bottom-up approach. And I do hope this bottom-up approach with time, it will develop so much, there will be no need for top-down, no reservation, nothing extra you have to do for girls. Why do you have to do anything extra for the girls at the government level? If they were given equal, a girl might be physically weaker than that of a boy, but their brain is equally strong, absolutely equally strong. So, in terms of doing science, a girl is as competent as boy. You know, even within the men, some are good, some are bad. It is exactly like that. There is no gender issue involved to it. So, from home, if you give them equal opportunity when you have grown up as a child, as a kid, then all this reservation will not be needed. And I do hope one day it will happen so that there is no extra care needed for the women. You know, she was so shy to talk because she has been taught at her home as a girl, you need to be shy. You always raise. So these are something that is taught in the house. It, it's in our society, it's in our culture, it's in our custom that we have to come up. You know, we have to overcome this barrier. And if we can do that, one day I do believe, very strongly believe, there will be nothing extra needed for the women. They are capable, completely capable.
Thank you, madam. Thank you very much for this enlightened talk that you gave today. It was a scientific satsang kind of thing. We were really mesmerized for 1 hour, how time passed to know. So thankful to very much. And if you can kindly consent, one day the university will be happy to invite you for a physical lecture. And we all will gather in an auditorium. And I think you know Sikha Verma, because through Sikha Verma, actually, I got your address. So
Yeah.
she is also in Bhubaneswar. And as Puri Jagannath Temple is such a sought after Tirtha place for all the Bengalis. So I think one day definitely we will be fortunate and privileged to have you amongst physical mode. And with these words, on behalf of the university, I am extremely grateful and thankful to you, ma'am. Thank you very much.
Thank you. Thank you. Thank you. Okay, now I'm leaving, so I hope it's fine.
Yes, madam. Yes, please.
Thank you. I also enjoyed the event. Thank you.
Thank you so much.